5, 6, 7, 8, 9, 10, 11.
Okay, that's it.
Lower surface tiles can protect up to 2,500 degrees. It is sometimes hard to believe that it protects it like it does. It's strictly real thin aluminum underneath, that's all it is.
113, 115, 106.
It's a giant jigsaw puzzle that has 35,000 different shapes and sizes of tiles.
Next row. 12, 20.
The tiles were masterpieces of thermodynamic engineering, but they were also a nightmare for developing and building a new vehicle. There were 31,000 tiles on the first shuttle on the Columbia. They all had to be put on by hand.
And it did seem like an endless job, like something we would never perfect. They were so fragile. It seemed like every time you were working on them, something went wrong.
It took a total of 670,000 hours to put them on, 335 man-years. A worker could install about 2 in a week. It was a nightmare.
If one sees an infrared image of the shuttle, you see that there are extremely hot places on the forward edges of the wings and the tails and other places on the fuselage.
We got quite a light show out here right now.
It was really like flying inside of a neon tube. We were looking out through there, and all of a sudden this glow started at about 300,000 feet.
There's this nice, soft orange light that surrounds the vehicle. It doesn't look all that hot, but it's there because it is hot.
We're sure looking at 2,000 to 3,000 degrees right outside the window. It was awesome and very impressive, and it worked.
In the Apollo days, when the capsules came in, all the heat protection burned off. But what we do now keeps the astronauts safe. Without us, it doesn't come back.
Then she rolls out of the orbiter processing facility. We take it to the VAB, which is the Vehicle Assembly Building, the big building.
And then it's brought to this 48-story immense modern cathedral that was designed for the Saturn V rocket, which was much bigger than the shuttle stack. And then it's taken with a crane and grabbed by the nose and hauled vertical, and then moved over and mated with its external tank, its expendable fuel tank, and the solid rockets, which themselves have been prepared for several months for this mating.
Although it appears we go overboard in some cases and things do seem to be laborious, there's a lot of thought process put into that. You know, the old carpenter's saw. You measure twice and cut once.
Clearly, the shuttle was sold on some false promises, and the most important of those false promises is that it would be routine and inexpensive.
Not only were there no savings, but the space shuttle has been fabulously more expensive than the expendable launch vehicles it replaced.
And it was very clear to many people from the very beginning that this was going to be a cost-ineffective white elephant. And in fact, it has been.
I wish there was an easy answer to how you ignite people's free interest in the exciting and tremendous idea of man going into space. When you think back on the old days, and one of the things that JFK was famous for having said, and that is, you take your very best hat and you wear it down the street, and when you come to a wall you know you can't scale, you throw it over. And then you just try to go get it, try to get it back, because you know you can if it means enough to you, and it's the way you find out how much you really can do.
I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to the earth.
Well, I guess what you could say about this room, and as you look in here down to where the met up with the Apollo spacecraft, was the final step off to the moon. This is a pretty historic piece of hardware to be laying out here in the sand, but brings back a lot of memories that'll look in there. And to see all these arms service the big Saturn. And what you see when you look at all this is you start to see, and I haven't been down here, been near this hardware in years, but you start to see the faces of the people and the way it was back then.
20 seconds and counting. T-minus 15 seconds. Guidance is internal. 12, 11, 10, 9. Ignition sequence starts. 6, 5, 4, 3, 2, 1.
And I guess the 25th anniversary of Apollo kind of puts it all in real perspective, you know, with how many years it's been and how far we've come, and this is what's left of that big program. It used to be so alive, I mean, now they're like the bones in a graveyard. It was a massive undertaking, and it took massive hardware, and it took massive people to do it. And they did a hell of a job, as history shows. Exciting show to see the arms coming back and then the arms coming back and then the hold down post-release, and it would start to climb out much, much slower than the shuttle today, and it just sort of held on to you for quite a while going up as it tried to clear the tower. It was gorgeous. Gus and Roger and Ed got killed in the fire. I guess I wasn't too surprised when that happened. I was sure sorry to miss Gus, because he was a great fellow. And so were Roger and Ed. I think if Gus hadn't gotten killed, he might have been the first person to go to the moon, which would have been good.
A friend of mine was showing me a computer game the other day called Civilization, and in that computer game, you get to build the wonders of the world. And one of the wonders of the world was the lunar program. And I thought, gee, that's rather odd that it's in the same category as pyramids and the Great Library of Alexandria and things like that. What an odd thing that this very high-tech thing is a wonder of the world. But in fact, you know, that is kind of how it's looked at, isn't it? That it was a one-time event, it was sustained for a while, and then it was no longer a continuing part of the human experience.